when on this table, okay, Max, how many correct predictions did you make? 6. Okay. And incorrect predictions, that means he made 4, right? So Max's odds are 6 to 4. Okay? So if I got even amount of correct and incorrect predictions, then my odds would have been 5 to 5, right? Okay, Trina, you said you only missed 1, right? So her odds are 9 to 1, okay? So there's a difference between odds and probability. Odds compare wins to losses, okay? Probability compares wins to total. You guys with me? Okay. So how do I know when to use which one? Well, the difference mainly is each outcome likely? Okay. You guys, the Kentucky Derby just happened last week. You guys, right? The Kentucky Derby with horses, right? I don't know how many horses are in it, maybe 20 or something like that, right? There's 20? Yeah. So does each horse have a 1 out of 20 chance of winning? No. There's some horses that are like way more likely to win. Like they almost always know between 1 or 2 horses which one are going to win before it even starts. Okay? Which is why when you bet on those ones that are more likely to win, you're going to make less money than if you bet on like one of the lowest end ones, right? Yep. And they end up winning, right? Like think the Olympics is happening, right? Simone Biles got sick so she couldn't compete, but if she did other gymnasts have an equal chance of beating her in a floor routine? No way, right? So the difference is when I'm using probability, okay, so the chances of rolling a dice, right? You actually have the same chance of getting each of the 6 sides, okay? So it's valuable to compare how many times I get a 2 to the total number of possibilities, right? But in like sports betting, Kentucky Derby, Olympics, even flipping a coin, when it turns out that each option is not the same probability, if you actually look at it, we use what are called odds instead. You guys with me? Okay. So let's talk about odds next. Here's how you calculate odds, okay? Step 1, determine the number of favorable outcomes. That's like our wins, okay? Step 2, determine the number of unfavorable outcomes, like our losses. Loses, losses. I always forget which one has 2 O's. And then step 3, you express the odds as a ratio. Again, odds are better in most sports because each team does not have the same likelihood of winning, right? No shade. But I'm not going to say Westlake football team has a chance 1 out of 10 because there's 10 schools, because that's not realistic, right? I have. I used to teach at Lone Peak. Their odds are much higher than 1 out of 10, right? Okay. I like Westlake better though, just so you guys know. Even though the football team has a hard time, but we're getting better every year. Okay, so in a game involving 6-sided dice, you will win if you roll a 1 or a 6. So how many possible wins are there? 2. So how many possible loses are there? 4. So instead of asking for, well, I'll talk about that in a second. What is happening? So if I want my odds in favor of winning, I'd say 2 to 4. But my odds in favor of losing would be 4 to 2. We're doing okay? Okay, so let's go back when we did probability the last couple days. if I wanted to know the probability of winning, not the odds of winning, the probability of winning, I'd say there's 2 out of 6 possibilities that make me win, right? Turn that into a percent for me. Odds aren't normally turned into percentages, but if they were, what would be my percent odds in favor of winning? No. 50, 2 out of 4. So again, they're not the same. One compares wins to total. Okay, that's better used. Even in a situation like this, it might be better to use probability. I just did the odds to try and help you understand what it meant, right? But probability is better when each outcome is the same likelihood, right? But in sports, Kentucky Derby, things like that, we don't usually use probabilities. We use odds because each team does not have the same likelihood of winning. So instead, we use the odds, which compares our wins to losses. So wins to total versus wins to losses. So last thing for today is I want to see if we can make a connection from what we did last time. Did we learn about a couple situations last class where sometimes each outcome is equally likely and sometimes each outcome is not equally likely? Does anyone remember what those are called? What did we learn about last class? Where we have we've got a vocab word for situations where each outcome is equally likely, and a vocab word for when each outcome is not equally likely. We learned about it last class. Let's see. What are our vocab words for those situations? Last thing. Yeah? There you go. Fair and unfair. Good, Maddie. Fair games are when each outcome is or is not equally likely. You remember? Fair games are when each outcome is or is not equally likely. Is. So probability is better used in fair games. And odds are used better in unfair games. Does that make sense? Okay, so part of your project when we're making these casino games is that I'm gonna want an aspect, and you don't have to, you can just start thinking about it. I'm gonna give you a good rubric next time on Friday. But in your games, I want 2 possible bets. One's gonna be a fair bet and one's gonna be an unfair bet. And then we'll talk about how to describe the probability versus the odds of each situation. Does anyone have any questions? Cool.